Greetings, everybody. This is Eric Andelin, Senior Workflow Advisor with SimActive, and you're joining us for the webinar, What are the Advantages of Lidar with Drones? And with me today, I have my guest, Maude Pelletier, President and CEO of Balko Technologies. Maude, say hi to everybody.
Yes, hi, everyone.
So Maude, again, we've met before, but give everybody a little bit of your background and what you're doing with your company.
Okay, perfect. Thanks a lot, Eric, for the invitation to this webinar first. So I'm the CEO and President, as Eric has mentioned, of Balko Technology. I started the first company in 2016, so this one is my second company. I have a lot of expertise in LiDAR data acquisition, as my first company was providing service. We were acquiring different type of geospatial data such as aerial image, thermal, multispectral, RGB, always synchronized with LiDAR sensors. We have done like tons of different service data acquisition and all the geometric processing for different kind of deliverables for multiple sector of activities. So this was my first company. So I gained a lot of expertise in how to do it properly in terms of flight parameters, flight planning, how to process and get the right workflow to make sure that the data was accurate, precise, and had the resolution that the customer was expecting in the deliverables. I started the Balko Technology in 2021. But really, the investment started in 2017. So before I started Balko Technology, we did 5 years of investment in the development of this project, in this product, and also the software. And then 2021, I opened this company, which we designed and built a modular LiDAR system for drones that also come with software for the processing to generate the calibrated, georeference, stripline adjusted, time match, and colorized point clouds directly through our software.
Wonderful, wonderful. And I always tell people that, LiDAR is a great product. Photogrammetry is still alive and well. And the two work together great. So, it's fascinating, the technology of LiDAR. Photogrammetry started, well, I was born, but you weren't. But LiDAR itself is relatively new. It's what, probably 20, 25 years old, something like that. I have to calculate my wife's age back to when she worked at Optech. So yeah, it's about that old. It's good stuff. It's really good stuff. And with the advent of drones over the last 8-10 years, everybody was clamoring for it to become something that was viable in the drone space. And of course, the challenge there was miniaturization, bringing costs down and things like that. And I can tell you personally, I've flown plenty of drones with LiDAR systems that it scares the heck out of me, just because of the bulk and the cost and how much time you can fly. Back 5 years ago, it almost wasn't worth it because, they were too heavy and all of that. So you're taking it a different way. So tell us a little bit about, why you decided, to go towards the modular route. Like you said, you've got plenty of experience processing LiDAR data. What brought you to that point?
Yeah. So when I started doing services through my first company, MVT Geosolutions, we were one of the first company in Canada to use LiDAR on a drone. And when I started, as you mentioned, the price was really high. Yeah? We were one of the first unit out on the market. Like I was the 23rd customer of the biggest company manufacturer of LiDAR for drone right now. So I was really at the really start of this industry and was really expensive. And I realized really fast that if I wanted to do to serve multiple sector of activities, to be able to provide what I wanted or what I needed for quality of data in terms of accuracy and resolution, I needed to have 2 or even 3 different sensors to be able to achieve the result and be always optimal. Cost was really high at that moment. I told myself, why is not just modular? Why can I not just change a laser, or can I not just change a camera? Because all the sector of activity has really different demands and specific demands. And sometimes you need multispectral camera, and sometimes you need thermal, and sometimes you need 1 centimeter precision, and other times you need so other times it's 10 centimeters precision. It's more than enough for mapping. And it's like, in fact, you just need to change a laser to improve the precision. And you just need to change the highness to improve the accuracy, which is a balance with the laser, of course. And the camera, I wanted to be able to be flexible and be able to provide all what I needed for my customers. So I said, I'm just going to, at that time, I thought it was going to be simple. I was like, oh, this is simple. I can just build my own Lidar and I will reduce the cost. And at first it was for my own operation. And finally, we did that. And in 2019, I realized what was the innovation that I just produced and how good it was. So we decided to commercialize it, and then we redo everything to optimize for the code and for the product to be easy to use, flexible. So really the modularity helped the customer to increase the performance of a LiDAR easily, rapidly, directly in the field, to be able to adapt their sensors to what they need to provide for the customer, instead of adapting the flight parameters. Yeah. Because right now you have just one package, like one LiDAR. It's all in a package. It all comes like with a 24 megapixel camera and let's say SI. Can it change it? It's one package, but if you want to be competitive in some type of sector of activity or some demand, then you need to reduce your height, reduce your speed, and then you're not optimized, which you're not competitive in regards of your price offer.
Yep. That's fascinating to go from, producing product on software side and deliverables of mapping to actually building and putting together components for people to do better at what they do. So before I get carried away and we continue on with the conversation, I just want to let everybody know what our topics are going to be. So the topics are going to be understanding the benefits of LiDAR and imagery, selecting the proper hardware configuration. This is where you come in. Planning for dual acquisition, again, your expertise, and then managing LiDAR and photogrammetry and correlated 3D, which I will go into a demo for folks. It's basic, but it's important. What are the benefits of LiDAR versus imagery?
There's multiple, of course. So first of all, the LiDAR works with light. It's a optic photonic solution. Mm-hmm. So I like to call it, because optic photonic, it's always a scary word, like what really it is. It's like, it seems like, but really light, it's in so many industries. Light, it's such an amazing, I wouldn't say technology, it's such an amazing information you can capture. So it works with light, and we calculate the speed of the return of that light, and we're able, with the information of the light, to position the XYZ information. So the 3D information, the measurements, it will penetrate the vegetation. So you can, it's like photogrammetry, as you know, it's an amazing tool as well, but it's a pixel. So you will get the surface of a tree. Correct. But with the LiDAR, you will really get the ground of the measurement. So this is one thing. Also, there's no difficulty when you fly. You can fly at night. You're not dependent of the light, such as the image. So you really can fly. There's no issue with the shadow. You will always get the same point cloud density. It's a consistent value for the density because it's the laser will work with a certain speed for the pulse, and depending on your speed and height, it will be constant on the density. So there's like the penetration, and also the accuracy you can get with the LiDAR is amazing, even through a dense vegetation. Let's just talk about, let's say, a river when there's shrub, really dense shrub along the river. You want to calculate the speed of the erosion along the river. Mm-hmm. There's not many technology that will provide a really dense point cloud in an easy way. If you won't do this with the scan laser. If you go with a GPS, you're just gonna have like a few points. And then the drone has like a really good advantage there because it penetrates even like really dense shrub to get really defined DTM, digital terrain model, through that vegetation, and then you can see really the form of this erosion. So anything that is related to having a really high point cloud density through vegetation, where a good, precise, and high resolution DTM is required, it is a really amazing technology for this. So I will say that Lidar and photogrammetry are complementary.
Yeah.
And a lot has definitely is role when it's regard to forestry, environment, vegetation type of ground survey.
I can say as an old photogrammetrist, who worked with stereo compilation and all of that, when we would come across vegetation operating in stereo, we would just draw a drip line around it and say everything in there we can't see. We can estimate, but we can't see it. So that always became the challenge. And to your point about being around water bodies tend to have vegetation along the sides of them. And you're right, it's a complementary. Photogrammetry and Lidar are complementary because Lidar will definitely get you that surface. And then, like you said, you can either colorize the point cloud with photogrammetry, or you can do photogrammetry and create your mosaics and so forth from that. So I just did that in my previous webinar. So that, I agree, fascinating stuff. So if I remember, Lidar is an active sensor, RGB is a passive sensor, correct? RGB needs light for it to be visible, whereas Lidar is active, it doesn't need light. And a lot of people who maybe don't fly don't realize it is very nice to collect your data at night. There's a lot less going on in the airspace. There's a lot less going on, to hinder what you're trying to do. So that's a very, very important point. Let's talk a little bit about hardware configuration. And it is truly important because you're right. If you just go to one of the big manufacturers of LiDAR units, they can put together a package for you that will work specifically for your need. But it tends to be in the drone world that your need is everything, because what you're doing today is not what you're doing tomorrow. And then when you couple that with imagery, you're changing things a lot. And I can tell you from my experience, the first few times I flew LiDAR units on drones, as you did probably, you had to turn the LiDAR on and the drone on, make sure the LiDAR was running before it ever left the ground, and then wait for it to come. There was no easy button. There was no easy way to do this. You plugged it in and hoped it worked. So I'm sure that's why you got to where you're going. But explain a little bit about, those things, the key points of selecting your hardware configuration.
I think that first you really need to ask yourself, what is the deliverable I want to get exactly? What's the accuracy? What's the precision and resolution? Do I need to vectorize? Do I need to do all the classification of all anthropic element and physical element? So the accuracy, the number of echo, like for penetration of the vegetation, this is all the different variables that you need to look to make sure you select the right technology, the right configuration. If you want to do an inspection job where you want to really get analyze the movement of a facade, for example, you will want to get the best resolution and the best precision, because you don't want that movement to be lost in the noise of the point cloud, actually. You want to really have a good position, a good resolution, to have enough point to do those deformation analysis of a structure. So really the driver of what is the right configuration is the type of industry you're working in and what is the deliverable you want to achieve. Because it's really that will decide what is the point cloud density or the resolution, or the precision and accuracy I need to achieve. The good thing with modular is that you can start with one sensors that do 75% of the job, and then when you want to refine, the results, then you just change the laser or you just change the highness, or depending on what you want to improve in terms of results.
So, I mean, honestly, with the way you set things up, they are just basically Lego blocks
Yeah,
that
exactly.
you can say, the project I was doing was construction work or something like that, where the accuracy only had to be, 10 centimeters or something like that. Now I'm getting something that I need to be in a 2 centimeter range. So first thing we need to change is the INS.
Exactly. It's really a quick release system, so it's really like different. And then just by quick release, you can change. Of course, all those configuration comes with a calibration profile, and there's a software as well. But the customer doesn't see anything. It's all in the background of the software. The software will recognize every different configuration according to what you decide to buy, and then we'll do all the correction and to transfer to a calibrated point cloud.
Okay, so very similar to in the RGB world for us on the software side at Correlated 3D. Anytime a new camera comes around, once we get the camera information, we can import that into the software. And when a customer comes along and they're working with that camera, all they have to do is select that camera, and the software already knows everything it needs to know about that camera.
And it's also the same. We have also an application that goes on an Android tablet. So it's called eConnect. eConnect allows all the data when you're flying to be, not the data, the information of the status of the different model. Like, so the LiDAR, the INS, all the information. How many satellites do you have? How much space left do you have on your USB? Do you have enough battery? So all the information is sent remotely in real time directly to the operator, so we can really see all the status and make sure that everything is functioning right, that it's recording, you have enough space, you have enough satellites. And also when you mentioned there was no easy before, a way to start a LiDAR it could be complicated, but with this application you don't even need to bend to start the LiDAR. You just swap swap it. I don't know, so directly on the tablet to turn in on the recording and turn in off the recording. So customer really cannot get it wrong. It's just like one swap and another swap to stop. So this really make the data acquisition really simple, and also make sure that the processing, it's a really simple way to process to make sure that everything is connected and well configured.
So, I mean, theoretically, the drone pilot doesn't even really have to know what the configuration is that's going on the drone. He may not know that this IMU is different than this IMU. The software is going to recognize it and fly accordingly. So is it tied to a flight management software, or is it just separate?
The flight management software is separate.
Okay.
So our payload is completely independent of the drone. We designed the mounting bracket that is quite flexible and modular as well, that fits most of the drone. I would say 80% of the drone can fit. So it comes with the mounting bracket to attach the LiDAR and system to the drone. But our payload has its own batteries, on GPS, on everything. So you can really use it on all different drones of your choice. So it evolved much better in time, because when you look at this, drone evolved much faster than payload. If you like a drone, in 4 years, you buy a drone, 4 years later, it's another drone, and so on. If it's all together and it's fixed, and if your drone is discontinuous, then it's also your LiDAR that it's discontinuous. With our sensors, it's not like that. You can just change a drone as much as you want.
Okay, so honestly, that brings me to it leads to my next question, which is, you, in many cases, may be working with both sensors, LiDAR, RGB, LiDAR, NIR, something like that. And each of those captures a different footprint. And a lot of the challenges we have when people bring a dual collect to us is that one sensor gets sacrificed. So, to get the point density they want from the LiDAR, they fly lower than optimal for the camera, because maybe the camera has a focal length or a field of view that is different. So when you put a package together and it goes to somebody who's flight planning, I imagine with the intelligence that you guys bring to the table is that you kind of build those so that they're as closely related as possible. I mean, explain to me how you guys deal with dual sensor systems.
Yeah, totally. All right. So first is when a customer purchases sensors from us, it comes also with a calculator program that allows to have all the information of the lidar you select for your planning, also all the camera and all the calculation regarding the field of view, the SWAT, and the GSD versus the accuracy, density, and all of this. And then you can know what is the flight line distance between two lines to have the proper overlap for both system. And you always want to have, let's say 75% for your camera, and you want 50% for your lidar. Mm-hmm. If the camera is not selected properly, then you will have to reduce the flight line distance, and then you don't get the full optimization of your lidar SWAT. And this is one of the problems. So we did have selected the selection of the camera we have, like the 61 megapixel, as a really good field of view, really wide field of view. And it's a full frame camera and allows actually to be almost identical with the lidar SWAT. So it is important. We also have the possibility to have a dual camera. However, we don't do dual RGB camera anymore because we realized that it was more data. And at the end, with the new camera that we launched, it was actually getting the same SWAT. So there was no more advantage to have a dual camera. It was increasing the weight, and it was also increasing the number of photos and data. So we skipped that one, but we still have dual camera available if you want to put, let's say, a multispectral and a RGB. However, yes, of course, the field of view of a multispectral is less than RGB. Yeah. So it had to be taken into consideration when you do a flight. So it depends of what you want. But this is all things that we will discuss with the customer according to what he wants to get for deliverable and how to get the proper configuration to be optimized. It might be not to be doing RGB and multispectral at the same time. It might be to do two flights separately sometimes.
Mm-hmm. So that's great because I mean I've had to build calculators for these things and it drives me crazy. So it is, yeah. That's why I don't fly drones anymore. But there wasn't that kind of help around 5 years ago. So it's really nice and refreshing that you go a little bit farther than just selling the sensor. So tell me this. So the next step of that then is the processing side, because a lot of people will go out and collect LiDAR data and they may run it through POSPAC, hand it to somebody and say, this is the best I could do. And it's not the best you could do. It's just what you know. So how do you guys go about taking the data from the drone to producing that clean point cloud?
Yeah. So there's one thing that is really important to know, and for all the customer, we provide this information, is really always get good raw data. And the first thing is to get good raw data. And it's all start from the flight planning and what you want to get. And this knowledge, unfortunately, on my side, I learned it the hard way because I was one of the first. There was no one to teach me. And I learned from those year expertise. And there's so many little things to know to be able to do it the right way. And when you get the good raw data, then it's easy process. There's no complication. The workflow is super simple. And that knowledge that we have at Balko coming from my expertise, it's been shared through my team. And we are sharing this through our customer. So when they purchase through us, one of the biggest value I think we bring to the customer is that knowledge, how to collect the data properly according to your needs, what you want. And then after, we start the processing and we explain exactly the POSPAC, how to generate, making sure that the trajectory is well corrected. And after, how to make sure the georeferencing. We do the strip line adjustment directly through our software. We can import the GCPs. We can do our MST calculation with our GCPs. If we need to do a time match, then you can use your GCPs to do a time match. So our software was made so it's simple. It's a simple workflow, but to ensure like the best quality in terms of precision and accuracy, the best functionality to bring to be able to get those accuracy and precision at the best value. So really, the key is get your raw data good, and after it's a simple workflow that it's also part of our training.
Okay, so and again, I'm showing my age here, but I remember in the past that you pretty much had to have a good understanding of POSPAC, and then you were probably going to go into some kind of Terra product, Terra Solid, Terra Match, Terra something, to get to a clean point cloud. So you guys can take it to a clean point cloud in your software, correct?
Exactly. So my software, what it does, it's raw data. At the end, raw data coming from the sensors, of course. Yeah. But after I will call it, there's the level 1, level 2, and level 3. The level 1 of processing is getting raw data to a good raw data. Yeah. There's raw data and a good raw data. Okay, this is a point cloud that it's clean. Okay, it's denoised, it's strip line adjusted, it's calibrated, it's georeferenced, the data that you can trust entirely for further processing. And after there's level 2, where it's all the classification, all the vectorization, level 2, and then you have level 3. Now that we have AI, artificial intelligence. Yeah. So this is the 3 level. Our software will get the level 1 and level 2 for classification. We don't do any vectorization now, okay, because it was not our priority. Our priority was really to get the level 1 as best as we could and give the more option for the customer to be able to control their data, the quality of their data, to be sure that when it's export, they can trust it entirely.
Yeah, and that's fantastic. And I would say the same of SimActive and correlated 3D. We stay in our lane. We don't do vectorization. We do, because there are plenty of people that do that. We just do image processing. We don't do Lidar processing because there are plenty of people that do that. We bring that Lidar data in to help out. And we have a little bit of crossover between us, but just a small amount, just as we would, or you would with, other stuff like Terra products or whatever, because they do classification too. But how much nicer is it if when you finish processing your point cloud in the software that you purchased with the system you purchased, that you can get to a colorized point cloud and a clean point cloud to then take into whatever you want and complete your processing.
Yeah, exactly. For sure. To have a colorized point cloud and everything that is well matched, and this is a really big value for the customer. So our software allows the colorization by direct georeferencing. All right. If the customer wants to do an orthophoto, we will work with partners, such as you are our partners. We will work with a partner so the customer can generate the orthophoto, and then he can colorize the point cloud using the orthophoto. Yep. One thing I tell my customer, don't do the processing twice. If you do an orthophoto, don't do direct georeferencing. You're doing it twice. It's one of the longest processing, doing an orthophoto and colorization by direct georeferencing. Yep. So if you want 80% of your work, it's always delivering an orthophoto, and then you better create an orthophoto and colorize a point cloud after. It's something that it's funny, but I start that often. People are doing twice the processing. Yeah. They are colorizing the point cloud, and after they are doing an orthophoto. It's so much faster to do an orthophoto and colorize, because the orthophoto processing takes a time as well. Yep. And the georeferencing takes time as well. So better to do it only once.
And we're the same way with SimActive. If you've already got a point cloud, that's a surface, and you can bring that in. You don't have to let the software build a surface through imagery. You've got one that you can use. So we're in the same boat there. So that is the last thing I was going to talk about, and we kind of covered it. And it's merging what we do with Lidar and with imagery. And I know you're aware that your customers are often doing just that. Once you get them to that clean product, it is now going to be either tied in with imagery, or you're going to have imagery with it that they can take. And I would assume out of your systems, if they're capturing imagery, then that imagery is going to come out with all of the positioning information and so forth, which makes it great to bring into our software. So can you talk a little bit about that?
Yeah, definitely. So our first we calibrate all our camera. So for external and internal orientation parameters, our software will also do the geotagging for any type of camera that it's RGB or spectral thermal. We'll geotag directly in the EXIF. The metadata of the image itself will be geotagging with the information, and we'll also export the EOP information for being able after to import the calibration value directly through the software of SimActive for the photogrammetry. So for SimActive or our other software, so you have all the information that you can use for photogrammetry, which will improve many things, which will reduce the speed of the processing because it doesn't have to do all the computing to get that information, and also will be more accurate for the position of the orthophoto itself. You can also generate UDPM or UDSM and import that during your photogrammetry processing. Sorry about that.
No problem. So, but that's a big point, because a lot of people that use drones for imagery, not even LiDAR, but just for imagery, they have this assumption in their head that they've actually got an INS system in their drone. And in most cases, they don't. Or it's very poor in grade. So when they provide a post-process solution with EOs from a drone that A, probably is on a gimbal, and B, also doesn't have, it's not that good a data set. But when somebody brings a data set that was captured in tandem with LiDAR, the LiDAR cannot be good without a quality INS, which means that the geotagging of the imagery comes from that quality INS. It's going to be good.
Yeah, and it's as you just mentioned, like it's a lot of it. Like it's also how the camera is fixed to the INX, so it's not moving the gimbal. So all your lever arm are correct or fixed. And also when you calibrate the camera, you also some like the focus. You have to fix the focus, and all this is managed when you have just a camera with a drone on a gimbal. It's moving. And they are using the IMU of the drone sometimes, but it's definitely not the same quality of IMU because it's used for navigation. It's not used for quality data accuracy. So it's really different type of INS.
Yeah. And that comes back again to what you said originally during the acquisition side. Plan for good acquisition, have the right equipment for that. You're going to have clean data to bring into the processing solution, and the output data will be clean and ready to be used somewhere else. So that does make life much easier.
Yeah, it's all start by the flight, how you get your data and which equipment you use. So you want something that it's all synchronized in time.
Yeah.
And if you use other technology or the drone and you don't calculate properly the latency or the recording, and there's a lot of things, like it needs to be synchronized, like really well synchronized in time, everything. So just a few seconds will make huge difference in the position of everything of different. So it's really equipment, the right technology, and the right integration as well. It's really important.
And what's great about this whole conversation we've had, we have not talked about any specific drone. We have just said it's what the drone is carrying, as long as the drone is capable of carrying it and it can meet the time of flying that you need and carry that weight, that it really doesn't matter. So
yeah. The drone is just a vehicle, such as a car for a LiDAR on a LiDAR model. Or a tripod for scan laser, terrestrial scan laser. Like it's only a vehicle. Do we talk about the core that's collecting the LiDAR, mobile LiDAR? Not really.
Never.
We don't. We don't care about it. Yeah, so it's the same here.
It's funny because I actually back in my days past before SimActive, I worked with Optech and brought the first dual sensor lidar system into the U.S. And we were successful with that system. We had it on top of a truck, and then I went to a company that had it on top of a van, and they built a rack to hold it up on top of the van, and the rack would do this. I'm like, no. You can't use
No.
something that flexible. And then, but I've seen the last time I drove mobile lidar, it was on the back of a small utility car. So you're right. Nobody ever thinks about what it was on. So
No.
that's a very good point. So with that, I'd like to thank you for joining us. We will bring up some LiDAR data. We will talk about how you merge that data set in correlated 3D and what kind of products you can produce from it. But again, I really want to thank you for your time. Thanks for joining us.
Well, thanks a lot for the invitation. I really did appreciate the webinar. It was great. Have a great day, everyone.
Great, perfect. All right, so let's take a look at the sample data set we have. And here it is. We've already done the AT. Everything's good. We've got GCPs. And if we need to look at that report real quick, we can. It is right here. And we'll look at the results. So we've got great results with our GCPs. You can see our RMS X, Y, and Z, and the checkpoints are right on point as well. So everything's good there. And let's go into the fun stuff. The next step would be to produce the DSM, which we would do right here. And we'll just set the resolution a little bit bigger than that for the demo. And we're good there. So we'll go ahead and process it. Now we can generate a point cloud here. And we can tell it what observations and to colorize it and to go ahead and process it. Now understand that this point cloud is going to come from the DSM. So we'll go ahead and run that so we can use it as a comparison. I've already created these files, so let's go ahead and look at those. And we will go ahead and load the DEM. So we have a digital surface model right here. I also created the digital terrain model, which is right here. And we have the colorized point cloud. Now note that this point cloud comes from Correlator 3D using the DSM. It is created and colorized before we ever create the mosaic. So pretty good time savings here. And I'll go ahead and grab that. And there you are. Now, again, all these things could be done in Correlator 3D with the imagery alone. In this case, the imagery came from Balko sensor. It was a Regal sensor and a Sony A5100 camera tied together. In this, I'm just showing you, here are the normal steps. And we can take a better look at this point cloud just for fun. I'm going to go ahead and change the view. And you can see the density of the point cloud from Correlator 3D. It looks pretty good. It does a good job of getting individual trees and things like that. So pretty nice stuff. As you can see, got some coverage on the edge of buildings and things like that. So pretty good stuff. Now, let's go ahead and bring in the data from Balko. Let me switch my views again. And now what we're going to do is we're going to import their LAS file. Before I do that though, let's look at the options we have here. We have import and we also have add to project. So if I go to add point cloud and I pick the point cloud that was provided by Balko, here it is. all it's going to do is load that point cloud. And there's a difference because we're just loading the point cloud at this point. We've not asked the software to convert it to a DSM. We've not asked for colorized RGB values to create a reference ortho. This is just bringing in a point cloud. And here we go. So in this case, their point cloud is colorized. And you can take a look. Here is the point cloud provided by Balko Tech. And if we just pop back to the one from Correlated 3D, you can see quite a bit of similarity between the two. So that's just something for you to be aware of. Now, go back to their point cloud. So again, that was one way to bring in a point cloud. Add to project, add point cloud. Now, let's show you the other options. Let's go ahead and delete this or remove it. And we're taking it out of the project directory. So what we want to do now is go ahead and I'll turn off this point cloud. And we have our DTM and DSM turned off. Let's import an LAS file. Now, see, things look a little bit different here. We're going to go ahead and go to Add Files. Here's that same file, open, and it's going to go ahead and load the metadata. So it's searching to see what's there. Now we've got an option. We can adjust the resolution, which I did. It's the same as it was for the DSM. Because I'm going to create a DEM. So what I want to do is turn this on. And I also want to extract the reference ortho. So we can go ahead and do that. And I would give it an output folder and an output image name. But again, I've done this already. So let me go ahead and load those for you. Let's load the Lidar surface. And it's right here, LASDEM. And you can see it looks pretty much the same as the surface from Correlated 3D. There's a little bit of missing data here. That's okay. It's just what that LiDAR unit captured. Over water, you're going to see stuff like that. And then the next thing would be to load the reference orthos that it created. Now, again, if this was a system that did not have a camera associated with it, then you would get a intensity image. But since we have color here, it's going to bring in a colorized reference ortho that it created. And we can go ahead and do that by just selecting Add, LAS image. And there it is. So here is the reference ortho that the software created. And it looks pretty nice. So, again, this is what you're getting for Balko Tech. It's already coming. It just needs to be brought into Correlated 3D, and then you can do further work with it. In this case, we'll move on a little bit. I'll go ahead and turn that off. And we'll go back to the two DEMs. So we've got the LAS DEM and the DSM. One thing we could do here is do a comparison. Let's say we want to do change detection between the two. So let's just do change detection. And we can look at the reference DEM will be the LAS file. And the comparison DEM will be the one created in Correlated 3D. And we can say detect differences between, I would say, 0 to 1 meters, because there shouldn't be a lot of change between the two. And we can go ahead and process that. And it's going to show us what the changes are. As you can see, we've got a meter in either direction, and we're pretty much right on with the LiDAR data set, with the exception of some of the stuff out in, the vegetation. So kind of just something for you to see what the relative accuracy between doing it with photogrammetry and doing it with Lidar is. If you've got a clear open surface, you're going to hit just as well with imagery as you would with Lidar. Now, in vegetation, that's not the case, and we're aware of that. Lidar will definitely help you out there. As you bring in the ground-only classification, you will get a much better result. And I'll go ahead and turn off the changes. Then the last thing we would do here would be to go and create our orthomosaic. So I'll switch back to the DSM. Actually, I want to use the DTM. And here's our DTM. The next step for us would be to go ahead and create the orthos and the mosaic. So let's go ahead and create the orthos. Everything looks good here. We could adjust some things if we want. And I'm going to go ahead and let all of that slide. Overlap, crop, all of that. Resolution, again, for demo purposes, just to make it go fast, we're going to go ahead and put it at 1. And let's run it. So we've got our finished orthos. So the next step would be to go ahead and create the mosaic. Here, I wouldn't change anything. I'd just let it run and process. But again, I'll spare you the time. I've already got it. So we'll just go ahead and load it. So I'll cancel that. And we'll go here to the mosaic and it'll load the mosaic. And here we have our mosaic. So those are all the steps in correlated 3D to go from raw imagery to a completed project. Now, the beauty of bringing something in from a company like Balko Tech with their systems is that you can shorten your DSM creation time. So in other words, you can skip that step. You also have the ability to get reference orthos from Balko Tech. They are a bit different than what we would do as a mosaicing process because the color balancing and all kinds of things like that. But you could compare for yourself. It's really nice to have two options. So you've got what you captured at Balko Tech processed in their software to create a point cloud and to create reference orthos, and that point cloud again is colorized. That is fantastic. And you can bring those into correlated 3D. You can shorten some of your processing workflow by converting their LiDAR point cloud into a surface, which then you could continue in all the steps with correlated 3D. So I really do think these two methods are complementary, because anytime you run across an issue or lose data with LiDAR, if you've got imagery, you can still solve most of your problems. So I would always say, if you're working with LiDAR, capture imagery as well. It's just a great backup. Plus, everybody knows what a color image looks like. A lot of people don't know what LiDAR, they can't wrap their heads around it. The files are big and all of those kinds of things. So keep that in mind. With that, I'd like to thank my guest, Maude. Thank you. I'd also like to thank those of you that attended the webinar. Again, if you submitted a question during the webinar, I'll make sure to get those answered for you as soon as possible. I'd also like to remind everyone that this webinar, as well as all of our previous webinars, are available on our website, simactive.com, where they can be found under the Learning tab. Additionally, this webinar will be converted to a podcast and made available in the next few days. Thanks again for joining us. Until next time.